Hello. Good morning. Just wait a minute or so for a few people to drop in. I am starting to realize, though, that my list of concurrent viewers is inaccurate, so I have to refresh the page if I want to know how many people are viewing. So I'll just keep doing that. Looks like we've just got a few people here right now, so we'll just hold off for a minute, and then we'll jump right on into it. Good morning. Okay. Maybe what we can do today is I'm going to start off with two questions. I'm going to start off with two questions. And I really like these questions. I just came across them recently. So we're going to do a little warm-up. So we're going to start off with, okay, here we go. Okay, so let me just center this properly. So that goes about right there. That goes right about there. Okay, that looks good. And then here is my center. And okay, so I've got this kind of situation here where I've got a circle, and what I'm going to do is I'm going to throw a triangle inside this circle, like so. And oops, that's not what I wanted. Something like this. Okay, so, and you know what, that triangle looks kind of bad, so I'm gonna say something like this. Okay, still looks kind of janky, but whatever. Good enough. So here's my triangle, and I've got an angle of 120 degrees. Okay. I want you to find the area of this region right here. Okay? Or maybe what I'll do is I'll use the highlighter. Yeah, the highlighter is much better. So yeah, I want you to find the area of this triangle. Okay, so that's your job. I'm going to give you just a couple minutes to do that. Let's say 2 minutes to find the area of the triangle. Oh, and I should also tell you the radius of the circle. Let's say that the radius, which happens to be one of the sides, is 4 centimeters. Okay, so I'm going to give you 2 minutes, and we'll just do this question while people show up to the stream. Oh, that's not what I want. No. Okay. Where is? There it is. Okay, 2 minutes starting now. Okay, find the area of the triangle. Okay, so that's the 2 minutes. I'm not going to solve this one for you, but I'll just kind of show you one way of doing it. Okay, so I'm going to copy this triangle out. So this is 4 centimeters. And the trick here is to try to find the height of the triangle, right? And that's going to give us basically a right angle triangle. So you could use our law here. So if this is 120 degrees, well, it's an isosceles triangle, which means that we've bisected this angle. So this is now 60 degrees, making this one 30 degrees. And you could use trigonometry here to solve for h. Okay, so I'm not gonna solve this one. What I want you to do, so if you haven't solved it yet, I want you to think about how you would solve it. And if you have solved it already, what I want you to do, so the extension to this problem is to find the area of that shaded region. So part 2, find the area of this. Okay, so that one you don't really use that much trigonometry, and it's an interesting problem. Oh, excuse me, I am tired. I got so much good sleep last night, though. I'm not sure why I'm so tired. Okay, so what we're going to talk about today is something called the ambiguous case. The ambiguous case. And this concerns the ASS triangle. Okay, so when you know the angle and 2 sides, but the angle looks something like this. So keep in mind, this is not the same as SAS. Here, I'll write it right here. Is not the same as SAS. Okay, SAS means that the angle is between 2 sides. Okay, so the angle that we know, the angle that we can measure, is between the 2 sides that we can measure. Okay, so remember, so SAS is going to look something like this. So I know this side, I know this angle, and I know this side. ASS is where we know the angle of something, but I don't know the length of one of the sides of the angle. I only know this side, and then I know this side. But I do not know this angle, right? So this angle is subject to change. And I also don't know this side. Okay, so that the length of that side is unknown. But I do know one of the angles, 2 of the sides, and in that order. Okay, but I do not know the angle between the 2 sides. So this angle is, who knows, right? So maybe the side actually looks more like this, or maybe it looks more like that. It's hard to say. So also we don't know the length of this side. So this side could be that long, could be this long, could be that long, right? So in this case, just the way it's been set up is there is an ambiguous, there's some ambiguity here, because sometimes you can actually have more than one solution. You could also have 0 solutions, etc. So this is kind of like where we are looking for the roots of a quadratic, right? So it's kind of like, well, here's our coordinate plane, right? We had situations where we had a quadratic like this, where we had 2 roots, right? We had situations like this where we had 1 root, and we had situations like this where we had no roots, right? The parabola did not cross the x-axis. So it's a similar situation to that, okay? So with that in mind, let's talk about how this works. So I've got a few different cases. So what we're going to do is I'm going to sort of draw sort of a template here. So this is my template. Okay. Okay, so this is the unknown side. Okay, so this is the unknown side, and this is the unknown angle. Okay, but I do know this side. So this purple side, I know. This, oops, that's not what I wanted. Come on. This side I also know. I know the length of these two sides, and I also know this angle. Okay. So another thing that I'm going to throw in here, just because it'll be useful to have on hand, is the height of the triangle. Okay, the height of the triangle. So we've seen here that we can pretty much always calculate the height of this triangle. So the way we would do that is we would say, okay, well, I know this angle, right? This angle I know, and I know this side, right? And I'd be looking for this. So this would be with respect to the trig ratios, I would be able to say that this h here can be calculated by taking, okay, so sine of our angle theta here. So this is our angle theta. So sine of theta is equal to, what is it, opposite over hypotenuse. So let's call this the side maybe A. So opposite over hypotenuse. So opposite in this case is h, hypotenuse is a. Okay, so h is equal to a times sine of theta. So in this case we can calculate h. So h is something that we can calculate and is not going to change. Okay, so even though there's a lot of unknowns about these triangles, the height of the triangle is something that is known. We can calculate the height of this triangle. Okay, so what we're going to do is I'm going to call this angle A, okay, which makes this side A, and then this side is going to be side B, and the unknown side, that is side C, which makes the unknown angle C. Okay, and that's a capital C. Okay, and if you have any questions about this, go ahead and ask them now in the chat. This is not going to be like super straightforward. I'm going to sort of warp your brain a little bit on this one. So if you have any misconceptions about how I'm naming these things or why things are the way they are, just ask now and I'll do my best to address that. Okay, so so we have a few different cases. Okay, so what we're going to be doing, we have three cases. Okay, the first case is that A is less than H. A is less than H. Okay, we have another case where A is equal to H, and the last case is where A is greater than H, but also I should also say that A is less than B. Okay, so in other words, if we wanted to sort of condense this into just one line, we could say that H is less than A, which is less than B. Okay, so so those are our cases. So yeah, let's see what we can do. And then I suppose that one other case is that A, if we want, we could have four cases, but let's just leave it at that. Okay, so, and you know what, let's actually have four cases. Let's turn this into four. I want to do this properly. So the fourth case, so this would be case 1, case 2, case 3, and then the fourth case would be where A is greater than B. Okay, so these are our four cases. So just keep in mind that H is a value that we can always calculate. Even with all of the unknowns about this, H is a value that you can always calculate. So just to be clear, where h is equal to b times sine of a. Okay, remember, because here's our right angle triangle, right? We can make our own right angle triangle because this angle is known. Even though this side, we don't know the length of this side, it doesn't really matter because all we need is just this angle. So we can make this right angle triangle. Here's h, so here's our opposite side to the angle that we know. This is a right angle. Okay, here's h. Here's our hypotenuse, which we're calling b. Okay, so using the sine function, the sine ratio, we can say that sine of a is equal to opposite over hypotenuse. Here's opposite, here's hypotenuse. So sine of a is equal to opposite over hypotenuse, h over b, or in other words, b is equal to, b is equal to, h is equal to b times sine of a, which is what we have here. Okay, so h is a value that we can always calculate. Are we not calculating angle b? So angle b would be over here. So if we did figure out this, we're not concerned with angle b yet. So really what we're saying is, okay, so I've got this ASS. I've got this ASS triangle, and so that means that I don't know this side. All I know is just this angle, and then the two sides that are kind of consecutive, right? They're adjacent sides. So I know this angle. So I don't know the, oops, didn't want to do that. I don't know this length. All I know is the angle between these two lines, and I know this side and this side. So yeah, we're not quite going to worry about the angle B yet, because once we figure everything else out about the triangle, then B will just reveal itself to us, and we can solve for B. But some things that we don't know this angle, so this angle is subject to change, and the length of this line is subject to change. So really what I'm saying is, if I gave you only a little bit of information about the triangle, I told you one angle and two sides, but the angle is not between those two sides, well, what can happen? What can happen? Well, let's talk about the first case, when A is less than H. When A is less than H. Okay, so let's reconstruct our little template. So here's my template, and what I'll do is I'm going to have red as a line that is unknown, and yellow is a line that is known. Okay, so there's my little, what do you call it? Legend. It's my legend. This class is legendary. Okay, so I know that I'm going to have something like this. So here's my sides. And what do I call these? B and A? Yeah, so this is side B, this is side A. And I do know this angle, but I do not know the length of this side. So I'm just going to make it really long, because I don't know how long it is. But once A, like once we figure out where A sort of like intersects with it, then boom, we know exactly the length of this. But what we'll see here is that we're not actually going to get an intersection. So on one thing that we do know the height. We know the height, but we do not know this angle here. So you might notice here, if A is less than H, when A is less than H, then you might notice it's actually impossible. It's impossible for this A to intersect with our side, I guess this was our side C, right? So we don't know the side C, and we don't know the angle C, right? So if A is less than H, that means like even if we sort of like like maybe A is here, maybe A is here, but we know that that like it's not possible. This is an impossible triangle. right? It doesn't matter what the angle of C is, right? We don't know that, right? So C could be anything here. It doesn't matter what your angle is, since A is less than H. It's not going to intersect with our side C. It's impossible. So this is an impossible triangle. So if someone were to tell you, hey, I've got this cool triangle that I want to tell you about, and then they tell you all the dimensions, and then this side A is less than the side than H, which is we can easily calculate, well, then you can be pretty sure that they're lying and that this triangle doesn't exist. Okay, so that's the first case. Okay, 2. This is when A is equal to H. Okay, so all of this really hinges on the length of A, right? I mean, H plays into it, and H is a function of this angle and B, right? So we really are comparing A to both B and our angle A here. But A is kind of like the variable that is kind of the most important, the one that we're comparing this H to. But remember that H is calculated from combining this angle and this side into the sine function, right? So we really are comparing all of these variables together, but A is the one that we're really focusing on. So when A is equal to H, well, let's see what this looks like. So here's my little template, and here's my little red line because I don't know what C is, and here's, I know this angle, this is the side B, this is the side A, here's my side H, and I think that's it. So when A is equal to H, well, let's see if that's possible. So I guess what I should do is I should make A actually as long as H, right? So that looks like about the same length, maybe just a wee bit longer. So it doesn't look like it's intersecting there. So, right, like that's not going to intersect the triangle here. So that's not possible. Well, you might notice that the only way for this to actually be a triangle is if A goes straight down. That's the only way it's possible, is when A goes straight down. So here A is actually the same as H, right? Not only in terms of the length, but they're actually the same length. And then boom, look at that. Now we have a nice little right angle triangle, and then boom, now we can solve for C. And this is actually a right angle triangle. So when A is equal to H, we get a right triangle. Simple as that. So that's pretty neat. Okay, now here's where things get interesting. This is where things get really interesting. Okay, so and let me know if you have any troubles with that about when A is equal to H, that means that we get a right triangle. Really, what we're saying is that it's the only way for this to be a triangle is if it's a right triangle, if the side A that we're given is equal to H. Okay, let's try this one. So this is case 3. This is when, what is it? B is less than A, which is less than H. No, other way around. When H is less than A, which is less than B. Is that what I wrote the first time, or did I write it wrong? Yeah, H is less than A, which is less than B. Okay. Okay, so in this case, let's think about what can happen. So, okay, so here is the side B, here, okay, and I don't know the length of this, so I'm just gonna extend it because we don't know how long it is, so let's just see how long it must be. Here's the angle that I know, and then here is A. Now here A, I'm gonna start off by drawing H. So here's my H. And, well, here's the thing. A is going to be longer than H, but shorter than B. So what I'm going to do, I'm just going to sort of draw it out here. going to draw it out here. And here's the thing, I don't know what this angle is. So I don't know that angle. How do I manage this? Okay, well let's think about what the possibilities are here. So here's my side. Here's the side that I know, and this is the side A, right? This is A. So here's the thing. We don't know what the angle is. So the angle could be anything. The angle could be anything. Well, let's see here. So let's see what some of my possibilities are. So if I were to sort of swing this thing down, you might notice that, yeah, I could get a triangle that looks something like this. You know, this could be my triangle here. So there's an option. There's an option. So there, A could look like that, right? But here's the thing. Here's the thing. What if we kept swinging it, right? So that's not really a triangle. That's not a triangle. Oh, look at that. There's another possibility here, right? So this is why we call this the ambiguous case, because there is some ambiguity. Remember that we don't know what this angle is. It could be this angle, or it could be this angle. We don't know. We're not told that information. But you can certainly see that we're getting two possibilities, right? So if I gave you an ASS triangle where this side here, the side, I guess it would be in this case this side, that's our side A. If the side A is less than B, so here's our side B. If it's less than B, but also greater than H, then there's two possibilities. There's two triangles that you can get out of that. Okay, so that's why we call it the ambiguous case. And this kind of diagram is kind of the way I sort of think about the ambiguous case. This is when I think about the ambiguous case, this is what's sort of baked inside my head, is this diagram here. So that's when when A is between H and B. We have two possible triangles that we could build out of this. Okay. Now finally, the fourth case, and this case isn't usually talked about, but I think that it's worth talking about. So this is when A is greater than B. Well, if A is greater than B, well, what that means is that, well, let's draw this. So here's angle, here's A, here's H, okay, and then here's the side that I don't know, and I don't know this angle, but I know this angle. Okay, so here's B, A, H, and then down here's C. Okay, so when A is bigger than B, well, that means it must be bigger than H as well. So, so certainly, like if A is bigger than B, well, then we're going to have something that looks kind of like this. Let's see here. You know, it's going to be bigger than B, so it's got to be over here like that. Now, you might try to do the same thing and kind of swing this side over to the other side, but if it's bigger than B, then there's no way that we can fit it inside here, right? So it's not actually an ambiguous case, right? So in this case, when A is bigger than B, we only have one case. This is just a regular oblique triangle. Okay, so that's just a regular oblique triangle, and we can use the sine law to solve this triangle. Okay. All right, so let's try an example of some of these. So let's see what an example can look like. Just let me pull one up here. Okay, let's try this. Okay, let's try, so given triangle ABC, let's try to, I'll give you the measurements as well. So angle A is 30 degrees. A is equal to 4, and B, I'm running out of room here, and B is equal to 10. Okay, we want to find angle B. Okay, so I'm gonna give you a minute to think about this one. Actually, I'll give you 2 minutes to think about it. And let me do this, and maybe 2.5 minutes, because you might have to think about this one. Okay, so I'll give you 2.5 minutes starting now. Think about this one. Okay, time's up, folks. Let's see what we have going on over here. Okay, so let's start off with a little diagram. So here is my 30-degree angle. Okay, so this is side A, and the opposite side to that is 4. So that would be, this would be 4. And let's see if we can actually make a triangle out of this. So I wonder if we actually do have an intersection. Okay, so let's see here. I've also have that B is equal to 10. B is equal to 10, or I should just write 10 here. Now let's see here. Okay, so and we are asked to find what was it? I think it was this angle here, right? So this would be, oops, the angle B, which is unknown, right? And I guess that this side is unknown as well, this side C. So let's just jump right into the sine law and see what happens. Okay. So if you want, you could calculate h, and I'll do that in a minute. You know, you could calculate h, but a quick way to do it is just to see what happens with the sine law. So using the sine law, so I know that sine of B over 10, right, is equal to sine of 30 over 4. Is sine of 30 over 4. Okay? So in other words, sine of b is equal to 10 over 4 times sine of 30, or in other words, 5 over 2. So 5 over 2 times sine of 30. And let me just pull out my calculator. So sine of 30 is equal to a half times 5 equals divided by 2 equals 1.25. So sine of b is equal to 1.25. That's not possible. That's not possible. Let's take a quick peek at what the sine function looks like. Okay, so sine S-I-N of, come on, I kind of hate this, sine of x. Okay, so this is what the sine function looks like when we graph it. And what you'll notice is that, oh, by the way, we're using radians here, not degrees. But in any case, what you'll notice is that the sine function never goes above or below, it never goes above positive 1 and never goes below negative 1. So here, apparently this sine of b is equal to 1.25. Well, you tell me which angle gives you 1.25. Well, I'll tell you what, you won't find one. None of these are going to go to 1.25. None of them. So yeah, this one, that's impossible. So that means that this is impossible. Okay. Now let's just verify that using kind of the methods that we used just a minute ago. So let's take a look at this side h, and well, h here is equal to what did I say? I think it's sine of 30 times 10. So times 10. So sine of 30, I think we said was sine of 30 is 0.5 times 10 is equal to 5. So here h is greater than a. So yeah, we do not have a triangle. This does not work. So no triangle. Okay. So the important thing to notice here is that in all the other cases, I can give you any angle and any two side lengths and it'll make a triangle. But in this ASS case, you have to be a little more careful. It doesn't always work. And here's an example of me giving you an angle and two sides and it not working. But you can imagine though, like if I gave you like SAS instead of ASS, well, here's a side. It can be any side length, any angle. Boom, it doesn't matter how big or how small it is. You could always make a triangle out of this, right? But with the SAS, it doesn't always work. It doesn't always work. Or sorry, the ASS doesn't always work. Sometimes it does. Sometimes it does, but sometimes, as you can see, it doesn't. Okay? I'm going to give you one more here. And this will be your exit slip. Okay, so exit slip. How many triangles satisfy, let's see here, angle A is equal to 30 degrees, A is equal to 7, and B is equal to 10. Okay, so that's your exit slip today. So how many triangles satisfy this situation where angle A is equal to 30 degrees, A is equal to 7, and B is equal to 10. Okay, so that's your exit slip for the day. Yeah, so I will be posting some homework very shortly on this material. This is our ambiguous case situation. Hopefully we can finish this off tomorrow, I think I'll do maybe just maybe just a bit of a review tomorrow on this stuff, and then we'll take it from there. So anyway, I hope you guys are doing well. I really miss you guys. And one thing, I just want to let you know that there may be a change to our final assessment. I just learned yesterday that apparently we're not allowed to do final exams or something like that. So it may turn out that we all do the project. I will let you know when I find out more information. I've sent out a few emails. I haven't heard back yet. But if I find out any information about that, I will let you know as soon as possible. But yeah, it's possible that we do not do a final exam. So yeah, I'll let you know as soon as I know for sure what that means. So take care. If you guys have any questions about any of this, as always, don't hesitate to reach out, and I'll talk to you guys tomorrow. Bye-bye.